Assalamu alaikum. Today we want to continue in this video the hydrocarbons. The objectives are recognize alkynes, apply IUPAC to give names for different alkynes, distinguish between skeletal and positional isomers, represent the hydrogenation of an alkyne. Recall back, the alkanes are saturated hydrocarbons, the alkenes are unsaturated hydrocarbons. The alkanes undergo a characteristic reaction which is substitution reaction. The alkenes undergo a characteristic reaction which is addition reaction. The hydrogenation reaction of an alkene produces an alkane. The halogenation reaction of an alkene produces an alkyl halide. The hydrohalogenation reaction of an alkene produces an alkyl halide. And the hydration reaction of an alkene produces an alcohol. Definition: alkynes are unsaturated hydrocarbons of general formula CnH2n-2 characterized by the presence of a triple bond C in the carbon chain. Nomenclature according to IUPAC system: the name of the alkyne that has the longest carbon chain containing the triple bond is derived from the alkane that has same number of carbon atoms by replacing the suffix a by -ine. Example: C4H10 butane and C4H6 butane. For the first molecular formula and the second molecular formula, we have the same number of carbon atoms. So the prefix of the nomenclature is the same, but according to the number of hydrogen atoms, we find here 10 H. So according to the general formula of butane, we have CnH2n plus 2 and 2 times 4, 8 plus 2, 10. So it is a butane, so the suffix is -ane. Here, according to the general formula CnH2n minus 2, we have 6 atoms of hydrogen, atoms of hydrogen. So the prefix, the suffix is -ine, because according to the general formula 2 times 4, 8 minus 2, 6. And this table must be studied by heart. The condensed structural formula of ethane C2H2. First, we put the carbon atoms and we put the triple bond between them, and we must distribute the hydrogen atoms between these two carbon atoms. First, we know that each carbon atom need 4 bonds to become stable. So the first one make 3 bond, so it need 1 bond, so it need 1 hydrogen, and the second the same. For the propoin C3H4, first we put the 3 carbon atoms and we put 1 triple bond between 2 carbon atoms, and the second one it's a single covalent bond, and we must distribute the hydrogen atoms between these 3 carbon atoms. The first one here make 3 bonds, so it need 1 hydrogen. The second make 4 bonds, so it doesn't need for any hydrogen carbon atom. And the third one make 1 bond, so it needs 3 hydrogen atoms. For n bigger than 3, number the chain so as to include both atoms of the triple bond, and begin numbering at the end of each chain nearer the triple bond, like the double bond. For example, C4H6. Here we must begin numbering. We must take the chain containing the triple bond, and we begin numbering at the end of each chain near the triple bond. So we must numbering from here, and we have the position of triple bond is on the first carbon atom, and we have 4 carbon atoms, so the nomenclature is 1 butane. 1 according to the position of the triple bond, and butane because we have 4 carbon atoms. Here the same, but here we can begin numbering from here or from there, the same, because the triple bond is still on the second carbon atom, and the nomenclature is 2 butane. Branched alkynes. When the carbon chain of the alkyne is branched, indicate the location of the substituent groups methyl, ethyl, propyl, isopropyl by the number of carbon atoms to which they are attached. For example, this condensed structural formula. First, we must take the longest carbon chain containing the triple bond, and we must numbering nearer to the triple bond, so we must begin numbering from here. And we have a methyl group here attached on the fourth carbon atom, so the nomenclature is 4 methyl 2 pentane, 2 according to the position of the triple covalent bond. Here the same, but we must begin numbering nearer to the triple bond, so we must numbering from here, and the triple covalent bond is on the second carbon chain. The group methyl is on the fourth carbon atom. The triple bond here is on the second carbon atom, and the methyl is on the fourth carbon atom, so the nomenclature is 4 methyl 2 pentane. Application 1. Write all the isomers condensed structural formula of C5H8 and give the nomenclature of each one. Okay. Solution of application 1. I take first the straight chain and I put the triple bond on the first carbon atom and between the first and the second carbon atom. So the nomenclature is pentane because we have 5 carbon atoms, and the position of a triple bond is on the first carbon atom, so the nomenclature is 1 pentane. Then I take the straight chain, but I change the position of the triple bond and I put it between the second and the third carbon atom. So the nomenclature is 2 according to the position of triple bond 2 pentane. Then I take this branched chain and I put a group methyl here on the third carbon atom, and the position of the triple bond on the first carbon atom. The nomenclature is 3 methyl because the methyl is on the third carbon atom, and the position of the triple bond is on the first carbon atom, so is 3 methyl 1 butane. Name the following compound. First, we must take the longest carbon chain containing the triple bond, then we must begin numbering nearer to the triple bond. So the longest carbon chain containing the triple bond is 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7, 8. So it's an octane. And the position of the triple bond is here, so we want begin numbering the chain nearer to the triple bond, so we must begin numbering from here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, and we have 2 group methyl and 1 ethyl, and according to the alphabetical order we must put ethyl before dimethyl. We have dimethyl, but we must don't take care about di or tri or tetra, etc. So we have ethyl and methyl, so E and M, so we put E first, then we put M. The nomenclature is 4 ethyl 4, 6, dimethyl 2-octane. Draw the condensed structural formula of the following hydrocarbon 2-ethyl 5-methyl 3-hexane. First, we start by hexane and we put 6 carbon atoms. Then we put the triple bond on the third carbon atom, and we have 2-ethyl, 2 on the second carbon atom. We put ethyl, and on the fifth carbon atom we put methyl. Is the name of the compound correct? If no, give the correct name. If we want to take the longest carbon chain containing the triple bond number from here, for example, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6, 7. So we have 7 carbon atoms and not 6 carbon atoms. And we have 2 methyl group. And we must begin numbering from nearer to the triple bond, and from here. 1, 2, 3, 4, 5, 6, 7. Then we have 2 methyl group on the second and on the fifth carbon atom. So the nomenclature is 2,5-dimethyl 3 according to the position of triple covalent bond heptane. Skeletal and positional isomers. Let's assign the skeletal and positional isomers of the formula C6H10. We take these 3 isomers of C6H10, but first let's read the definition of positional isomers. The positional isomers of alkynes have the same main chain of carbon atoms, but have the triple bond at different positions. So from these 3 isomers that have the same main chain of carbon atoms, A and B, and but have the triple bond at different positions, A and B have the same main chain of carbon atom but different position of triple bond. So A and B are positional isomers. Skeletal isomers of alkyne have different main chain of carbon atoms with respect to the triple bond. Let's see here on for A and C. A and C have different main chain of carbon atoms, but the 2 isomers respect the position of the triple bond. The 2 have the triple bond on the first carbon atom. So A and C are skeletal isomers. Application 2 indicate the positional isomers and the skeletal isomers of the isomers in application 1. Solution of application 1. Positional isomers. First, we take the 2 isomers that have the same chain but different position of triple bond. Then we see that here that the nomenclature is the same, but the position of the triple bond is different. For the skeletal isomers, we take first a straight chain and branched chain. So they have a different chain, but the position of the triple bond is the same. So here the nomenclature is different, but the position of the triple bond is the same. Reaction of alkynes. Unlike alkanes, alkynes have very great chemical reactivity compared to the alkenes. This is due to the presence of triple bond in their molecules. The principal reaction of the alkynes is addition across the triple bond to form alkanes. These addition reactions are analogous to those of the alkenes. Alkynes undergo catalytic hydrogenation with the same catalysts used in alkene hydrogenation: platinum, palladium, nickel, and rhodium. Addition reactions. The addition reactions of alkynes consist of adding 1 or 2 molecules of XY on the alkyne molecule. XY can be H2 or Br2, Cl2, H2O, etc. But here we must take only 2 reactions, 2 chemical reactions. The first one is the catalytic hydrogenation of alkynes. The hydrogenation reaction of alkyne consists of 2 stages. 2 molecules of hydrogen H2 add to 1 molecule of alkyne. If we take first the general formula, we have alkyne CnH2n minus 2 plus H2, 1 molecule. Here I add 1 molecule for the alkyne, and we must use as catalyst nickel or palladium or platinum in presence of heat. So all the hydrogen must be added on CnH2n minus 2, and we obtain 1 product. So the alkyne become alkene. If we take the alkene, because it have a double covalent bond, and I can add H2 on this double covalent bond, so we put H2 and the alkene becomes alkane. Condensed structural formula. If I take the condensed structural formula of Propoin, for example, and I want to add 1 molecule of H2, so I want to add it on the triple covalent bond and on the carbon atom just next to the triple covalent bond. And I want to break 1 bond only. The triple becomes a double covalent bond. I want to add on the first carbon atom hydrogen and on the second carbon atom hydrogen, so I obtain CH2 double CH3 propene, so the propoin becomes a propene. And if I want to take the propene and I want to add a second hydrogen molecule, so I want to add it on the double covalent bond and on the carbon atom just next to the double covalent bond, so I add on the first carbon atom hydrogen, and the product becomes CH3, and on the second CH2 CH3, and the double covalent bond becomes single covalent bond. So here remember that I want to use the catalyst nickel, palladium or platinum, and in presence of heat, and we must remember that if I want to make an addition reaction, the reactants are transformed into 1 product, only 1 product, we obtain 1 product. If I want to take the overall equation, if I want to add from the beginning on the propine 2 molecules of hydrogen, so I want to break the bonds, and the triple covalent bond becomes single covalent bond, and I add on the first carbon atom 2 hydrogen and on the second 2 hydrogen, and the molecule becomes, the product becomes CH3, CH2, CH3, and the propine becomes propane. Summing up, the general formula of alkynes is CnH2n-2 characterized by the presence of a triple bond in the carbon chain. Number the chain so as to include both atoms of the triple bond, and begin numbering at the end of each chain nearer the triple bond. There are 2 kinds of isomerism, positional and skeletal isomerism. The alkynes undergo a characteristic reaction, which is addition reaction. The hydrogenation reaction of alkynes consists of adding 1 or 2 molecules of H2 to 1 molecule of alkynes. Assignment: we have to solve the number 7, part D and E, and page 273, and number 8, part E and F, in page 274 in chemistry book. Thanks for your attention, وإن شاء الله بشوفكم على خير يا رب.